For this problem, we have a table that tells us the number of butterflies over time. And for the first problem, we are trying to find an approximation for h prime of 8. So we're going to find our approximation by figuring out the rate of change as close to 8 days as possible. So we have the number for 7, we have the number for 9. We can use the formula for average rate of change between 7 and 9. I'm actually going to write an approximately equal to because this is not going to give me the exact value of the derivative evaluated at 8. So if you don't remember the formula for average rate of change, I do recommend that you look it up. You most likely will be asked that on the AP test. You do h of 9 minus h of 7 over 9 minus 7. H of 9 is 11, h of 7 is 7. We end up getting 4 over 2, which gives us 2. Now, make sure that you also have your correct units, and you need an interpretation. So for the units, the easiest way to figure it out is top of the fraction is number of butterflies. Bottom of the fraction is days. So it's going to be the number of butterflies per day. So still not done. I have the units, but now I need to write an interpretation. So what's happening is that on day 8, the number of butterflies is increasing at a rate of approximately 2 butterflies per day. In order to get full credit on this problem, first of all, you need 2. That gives you 1 point. The second thing is you need the interpretation. And you either need to mention butterflies per day up here, or you can just mention it in the interpretation somewhere. You also want to mention that we're on day 8. You have to use that 8 in there somewhere. And you should mention that the rate is increasing, and you should also mention that it's an approximation. So for this type of question, I'm hoping that you've seen enough that are this setup that you know that this is one of the theorems. The 3 theorems, by the way, that you usually see are the intermediate value theorem, the mean value theorem, and the extreme value theorem. Actually, occasionally you'll see Rolle's theorem also. The mean value and the intermediate value are the 2 that will probably come up. Those ones are the most common ones. Now, the other 2 do occasionally come up, but the mean value and intermediate would be the ones that I would say you should probably study. So explain why there must be at least one time t for t is between 0 and 14 such that h prime of t equals 1.5. Actually, if you notice, this one is a derivative. That's a sign that you're going to be using the mean value theorem. So first thing you need to do for any of those theorems is check and make sure it's continuous. We know that it's continuous actually because in the intro for the problem, they mentioned that the function was differentiable. So because it's differentiable, it's also continuous. The next thing that you're going to do is you are going to make sure that the rate of change, the average rate of change, does actually give you 1.5. If it doesn't, then you're not going to be able to do this problem. So usually it will have something like that. You end up getting 21 over 14. That does reduce down to 3 over 2, which is 1.5. So we're good on that one. So you can say, and then by the mean value theorem, there is at least one time t such that h prime of t equals 1.5. So you can just do what I did. I just pretty much restated the question. That's perfectly fine if you're not sure what to write. So in order to get full credit on this problem, you need to mention continuity or differentiability, or preferably both. You need to find the average rate of change. and you need to make your conclusion. You have to mention by name the mean value theorem. If you write MVT, that's sufficient. The graders will know that that's the mean value theorem. So for part C, we are using a left Riemann sum to make an approximation of this integral. So the left Riemann sum is going to mean that we're going to use the points on the left, and we're going to use rectangles from there. I usually like to draw a picture. My one caution is that if you draw a picture, you probably should cross it out after you're done with it, unless you're sure that the picture is correct for the equation. My picture, I just drew a quick sketch. It's not to scale. I don't want the AP readers to grade it, so I'm going to cross it out. So you're going to start by, I just like to draw little rectangles, just like that. You'll notice I didn't actually use the 1422. So they told me the subintervals to use. Oftentimes they'll tell you to use 3 subintervals, or they'll tell you to use 5 subintervals. In this one, they actually gave you the specific places where they want you to use them, so make sure that you're actually doing that. From there, we are then going to find the area of each one of these rectangles. This one has a width of 5 and a height of 1. This one has a width of 4 and a height of 4. And then this last one has a width of 5 and a height of 11. So if I find that area, I do get that it is about 76. The next thing that they're going to ask you is this approximation greater than or less than the actual integral? So they gave us one thing in the intro that you may not have noticed because it's not really obvious. They told you the function was increasing, which you might be able to guess based on the values that you had. So what that means is the function is going to be kind of going up like this. You hopefully can tell that the estimate that you gave is an under approximation. It's an underestimate. So that means that it's going to be less than the actual integral. And the reason for that, you don't need to overthink it, is just because you're using a left Riemann sum and the function is increasing. So in order to get full credit on this problem, you need to, first of all, do this approximation correctly. You need to actually do this setup correctly. That's hopefully an easy-ish 2 points. And then for the third point, you need to give a good explanation. Oh, and again, as I mentioned earlier, cross out the thing that you drew. This one, they might actually take off points for what I drew because I tried to draw a graph on there and we don't actually know what the graph looks like, so just be aware of that. If you draw anything extra just to help yourself, that's fine. Just cross it out so it doesn't get graded. So for part D, this one is a little bit trickier. They give you a function to model the number of bees, and they want to know if the number of bees is increasing at an increasing rate, increasing at a decreasing rate, or neither. So increasing, we can find if the derivative is positive. Increasing at an increasing rate is going to occur if the second derivative is positive. And then for the second situation would occur, it would be increasing at a decreasing rate if the derivative was positive and the second derivative was negative. So this one's a little bit weird because they always like to throw in something that you may or may not have seen. And then they ask you, what can you conclude about the graph? So let's go ahead and first find the derivative, and then second we'll find the second derivative. So I'm going to tell you right now, this type of problem, you can do this on your calculator if you remember how to evaluate a derivative at a certain point. I'm going to just do it by hand, just in case you want to review how to do that. So this one, I'm going to use the chain rule. For both the cosine and the exponent, this actually should be 2 sine. That's going to give me g prime of t. By the way, I just noticed this problem has a typo. Right here, these should be t's. So now I'm going to evaluate g prime of 8. I do end up getting that my derivative evaluated at 8 is e. E is a positive number. It's about 2.7-ish. So since I know that it's positive, the first thing I know is that the function is increasing at time t equals 8. So that's a good start. So I know that it's increasing. The next thing I need to figure out is if it's increasing at an increasing rate or if it's increasing at a decreasing rate. I'm going to do that by finding g double prime. So I find the second derivative. This is what I get. If I do g double prime of 8, I end up getting 1/7 times e minus 4. You can evaluate that on your calculator, or if you know that 1/7 of e, which is about 2.7, you know that that's less than 4. So that's a sign that g double prime of 8 is less than 0. Because of that, we know that the number of b's is increasing at a decreasing rate. So this actually is a pretty good summary since g prime of 8 is greater than 0, g double prime of 8 is less than 0, the number of b's is increasing at a decreasing rate. The last thing that they ask you on this is, based on your answer, what can you conclude about the graph of g of t at t equals 8? So I can actually conclude 2 things. The first thing I know is that my derivative is positive. The second thing I know is that my second derivative is negative. A positive derivative means the graph is increasing, which I actually already stated, but it doesn't hurt to say it again. A negative second derivative means the graph is concave down. So in order to get full credit on this problem, the first thing that you needed to mention was that the number of b's was increasing at a decreasing rate. You also had to mention the reason why was those 2 things that I know about the derivative and second derivative. The second thing is we had to mention that it was increasing and concave down. And that actually had to be tied to the same reason. If you mentioned, by the way, for the second part, if you just mentioned concave down and not increasing, that's fine because you already mentioned increasing previously. But these are the 2 things that we're looking for on this problem. So part E is a really interesting problem. They actually give us the number of bees spotted based on the temperature. Believe it or not, this is a related rates problem. So they tell you when the number of bees spotted is 100, the daily high temperature is increasing at a rate of 2 degrees Fahrenheit per day. So before I do anything else, I am going to actually define my variables just to make this a little bit easier to look at. So B is the number of bees. X is the temperature. So the other thing that they tell me is that my temperature is increasing at a rate of 2 degrees Fahrenheit per day. When you see the word rate in calculus, that is often a sign that it is going to be a derivative. So an increase means it's positive, this rate right here is going to be the increase in temperature per day, which ends up being dx dt. And we know that that's equal to 2 when B is equal to 100. The next thing they ask us, they say, how quickly is the number of bees changing when 100 bees are spotted? So what they're looking for is the rate of change of bees. They are looking for dB dt. There are a few things that we need to do with this problem. So first thing I'm going to do is I'm going to see if I can write an expression that relates dB dt and dx dt. So I'm going to take that original equation and I need to find the derivative with respect to t. I actually like to, first of all, whenever I have a square root, I always like to rewrite it so that it's to the 1/2 power. So my dB dt is going to be, so it's going to be 50 times 1/2 times k plus 2x to the negative 1/2. Now I need to use the chain rule, and that is using the chain rule, but I need to multiply by the inside, the derivative of the inside, which is going to be 2, but I also need to multiply by dx dt. This is implicit differentiation. I do recommend, if you don't remember how to do this, you might want to review implicit differentiation and you might want to review related rate. So now I end up getting dB dt is equal to 50 over the square root of k plus 2x times dx dt. So I'm now off to a pretty good start. I have an equation that relates dB dt with dx dt. Unfortunately, I don't know k, and I actually don't know x at this point. So I need to figure out 2 more variables here before I can do anything else. So I know a few things. I have this equation b of x is equal to 50 times k plus 2x. I am looking for the x and the k when b is equal to 100. So I can start by writing an equation there. I end up getting 2 is equal to the square root of k plus 2x, which gives me 4 is equal to k plus 2x. So I'm off to an okay start here. So I'm going to solve this for k. I don't actually get something nice, but I do get that k is 4 minus 2x. So I don't actually get a number, I get an expression. The good thing is I can plug that expression into the k up here. When I do that, I get dB dt is equal to 50 over the square root of 4 minus 2x plus 2x. This is really nice because the x's cancel out. That isn't always going to happen with this type of problem, but most likely you're not going to be assigned a problem where you don't have some little trick like that. Then I know that when b is 100 that this dx dt is going to be equal to 2. So I can plug that in. I end up getting 50 over the square root of 4, which is 2, multiplied by 2. So actually my dB dt is going to be 50. They don't actually tell you that you need units, but you might want to just mention it. It's going to be bees per day. So for this problem, in order to get full credit, you need to, first of all, you have to get this part that I boxed right here. You need to use the chain rule related rates to find dB dt. The second thing is you need to get this little thing right here. You need to somehow, there's a few ways to do it. You need to somehow get that this right here is equal to 25. There is another way to do it. I'm not going to bother showing you the other way. It's a lot harder. But if you did it a different way and you got a 25 here, and then you multiplied that by dx dt, which gives you 2, that's fine. And then the third point is for getting 50.